Okay, I'm going to talk about propositional logic today. I've made some videos, but when I put on my canvas, they I don't know, something happens and they disappear. So I'm using YouTube now because Canvas isn't working. Okay, so let me explain how to do these propositional logic. So I have four statements here. P stands for today is Monday. Q, there is a test. R, we will have a party. And S, we will have a good time. These are called statement letters. Okay, statement letters. They stand for statements or propositions. Statement letters, or they're also called sentences, or WFFs, well-formed formulas. They're often referred to as WFFs, well-formed formulas. Okay? But I'll refer to them as statements. So, if you want to say, if today is Monday, then there is a test, you do this. You use the arrow. If today is Monday, there is a test. I'll use the arrow. A lot of logic books will use the horseshoe, like this. Okay? You'll see that a lot. But I'm not going to use the horseshoe. I like the horseshoe actually better, but I won't use it. I'll use the arrow. That means if P then Q. The antecedent, the consequent. The first term is the antecedent. A-N-T-E. Ante means before. Antecedent. The consequent. Q is the consequent. Okay? Antecedent, consequent. This is a conditional statement. If P then Q is called a conditional statement. Your book talks about all this stuff, so I'm not saying anything new. If P then Q, if today is Monday, there is a test. P, this is a deductive argument. Today is Monday. What follows from that? There's a test. Any argument that has that form is a valid argument. That's a valid argument form. If it's a cat, then it's an animal. It's a cat, then it's an animal. If it's a cat, then it's a scientist. It's a cat, therefore it's a scientist. It doesn't matter whether these are true or false. It just means that if this is true, and if that's true, this has to be true. And that's what a deductively valid argument means. If the premises are true, the conclusion has to be true. It's impossible for this to be true and that to be true and that to be false. This is called Modus Ponens. Any argument form that has, any argument, deductive argument has this form, it's called Modus Ponens. That comes from Latin. The Romans were very good at formalizing arguments. So this is called Modus Ponens. If P then Q, PQ. If A then B, AB. The letters don't matter. These are called statement letters. This is a deductive argument form. Okay, if I said if P then Q, let's say I say not Q, therefore not P. That's also a valid argument form, so this is valid too. If today is Monday, there's a test. There's not a test, then today cannot be Monday. If there's not a test, it can't be Monday because if today is Monday, there's a test. This is called Modus Tollens. Modus Tollens, T-O-L-L-E-N-S. Okay, that's a valid argument form. If it's a cat, then it's an animal. It's not an animal, it's not a cat. Any argument that has that form is always valid. Okay, so basically memorize just memorize the form. Okay? I'll show you another valid. This is going to be invalid. This is going to be no good. If P then Q, QP, that's invalid. You can't go backwards. Going backwards from Q to P, QP. That's I call that going backwards. In a conditional statement, you can't go backwards. You can go forwards, but you can't go backwards. QP, QP. Not backwards. If today is Monday, there's a test. There's a test. Does that mean today is Monday? No. It could be Tuesday. It could be a test on Monday and Tuesday. So if today is Monday, there's a test. Today is Tuesday, there's a test. You know? So that's invalid. If it's a cat, then it's an animal. It's an animal that's a cat. No. Okay, that's a fallacy of affirming the consequent. Antecedent consequent, I'm affirming the consequent is Q, putting that as a premise. Here's another invalid form. If P, then Q, not P, not Q. That's no good. If it's an animal, then it's a cat. If it's a cat, then it's an animal. True. It's not a cat, therefore it's not an animal. That could be a dog, elephant, whatever. So that's an invalid form. So I gave you two invalid, two valid forms. Now let me do one where I use P, Q, and R. I'll give you a chain argument. This is called a chain argument now. Chain, because different links. This is going to be a link, link, and a link. Okay? That's a valid argument form. If P, then Q. If Q, then R. If P, then R. You can always go forwards when with the arrow. P to R. If P, then Q. If Q, then R. If P, then R. If today is Monday, there's a test. If there's a test, we will have a party. If today is Monday, we will have a party. Then that's a valid argument form. That's a chain argument. I could make it pretty much the same by just getting rid of the conditional and putting the P as a premise, and then it will also be valid. It's still a chain argument. If P, then Q. If Q, then R. P is the case, so therefore R is the case. I'll do one with S, because you could go on, STU, it doesn't matter, but let's do if R then S. Then we could say if P then S, right? And you could go if S then T, if T then U, and so on. So that's a valid. These are chain arguments. So, yeah, it's, some of these will be on the final exam. I'm sending you a study guide that will give you some examples. You should know also in the book. You should go over these in some of the problems in the book. That deal with propositional arguments. Make sure you could do them. Let me show you something else. Okay, I'm going to show you something else about. I'm not going to do the square of opposition, but let me just show you the square of opposition anyway. It's not going to be on the test. AEIO statements, right? A is all S or P, no S or P, some S or P, some S or not P, all S or P. This is from the beginning of chapter 8. No S or P. This is not propositional logic. This is categorical logic. No S or P, some S or P. I just want to mention this because I didn't talk about it, and I didn't. So it's not going to be on the test, but I want to explain it anyway. So if you're interested, some S or P, some S or not P. Now, if we're assuming that this is called the traditional square of opposition. It's assuming, this is what Aristotle did. Aristotle assumed when you say all S or P, it means there's at least one S. So all cats are animals, there's at least one cat. So if we're assuming existence, there is an S term. If A is true, it has to be that the O statement is false. These are contradictory. This is in your book. So I'm not going to, you could check it out. I'm not going to go over too much. If this is true, that's false. If this is false, then you could go up. Then that's false. These are contradictory statements. When you go the diagonal, contradictory, always opposites. False becomes true. This is called the square of opposition. That's all I'm going to say about it. If you're interested, it's not going to be on the test. It's in chapter 8. It shows you how the A, E, I, O statements are related logically to one another. But that's not going to be on the test, so I'm not going to say anything more about it. So let me go let me tell you what the P and Q. These are the and is called an operator or a connective. Basically, propositional logic is a very simple language. It has letters, atomic statements called statement letters. Atomic because you can't break them up anymore. There's the simplest elements. That means P and Q, the ampersand. The V or the val, P or Q. If P, then Q. And P, if and only if Q. That's if and only, that's a double arrow. That means if P, then Q, and if Q, then P. Okay, so it means both. And then the not P or not Q. That's the tilde. It means, in Canvas, I'll just use the dash because they don't have a tilde. So that means it's not P, not Q. One interesting thing about the negation sign is that not P, today is not Monday. You can always cancel two P's out. Not P is the same thing as P. If you have not, today is not Monday, you can always take two away. Not Monday is the same thing as today is not Monday. So that's the negation sign. That's how that works. Okay, so anyway, propositional logic is I'm not going to ask you a lot on the, you just need to be able to diagram simple arguments in deductive logic that there's not going to be anything more complicated. I'll give you a passage in English. The hard part is really getting it into the form. It's really not that hard, but that's the hardest part. And then basically I'll give you an argument and then you put in this form, then you tell me valid or invalid, okay? So if by looking at it, you should just say that's an invalid argument. Okay, you just study it until you know it. And I talked, I think in another video, the truth table for the arrow. The truth table tells you exactly what this means. So if you have two statements, you have four possibilities. This is how you do it. TTFF. I'm not going to get into the details of truth because, we only have another week or so left. So you could do this on your own if you want, but I'm not going to get into it. Into the derivations. The arrow, the only time if P then Q is false is for line 2. All the other ones are true. So basically when you say if today is Monday, there's a test. The only time that is taken to be false is if today is Monday is true and there's a test is false. This is a truth functional statement. P then, whenever you use the arrow or the ampersand or the arrow, these are truth functional statements. And they're truth functional because the whole truth of the whole statement is a function. It depends upon the truth values of the parts, the P and the Q. Okay, that's all I'm going to do because my 15 minutes are running out. So I'll do another video, but for right now, I'll stop at this point.